bincang.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okey, Assalamualaikum warahmatullahi wabarakatuh dan hai semua para guru, ibu bapa dan anak-anak pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi YouTuber, bersama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Sebelum kita mulakan kelas, marilah kita membaca ummul kitab Al-Fatihah. Untuk yang bukan Islam bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Okay, amin, amin, ya Rabbal Alamin. Okay, apa khabar adik-adik semua? Cikgu harap semua berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada hari ini. Cikgu percaya adik-adik dah tak sabar untuk meneruskan kelas kita kali ini. Jadi cikgu perkenalkan diri dahulu. Nama cikgu adalah Nur Izian binti Saleh dari SMK Teluk Parlimen Garang, Selangor. Boleh panggil Cikgu Izian selaku moderator pada petang ini. Okay, pada petang ini kita bersiaran secara langsung dari channel Cikgu P. Siapa yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr. P. Nama sebenar beliau adalah Mr. P. Kok Hua dari Kolej Tingkatan 6 Tun Fatimah Melaka. Okey, hari ini kita akan mempelajari tajuk 3.1 Elektrik dan Beza Keupayaan ataupun untuk belajar di LP, Electric and Potential Difference. Okay, kelas ini akan berlangsung lebih kurang 1 jam. Selain itu, kita ada juga Cikgu Hasnita selaku ketua panitia dan juga control host dari SMK Bagan Jaya Batuut Pulau Pinang. Okay, sebelum kita teruskan kelas kita, jadi cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen untuk menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Okey, jadi seperti biasa, link e-sijil akan diberikan di hujung siaran nanti. Pastikan diisi dalam tempoh 30 minit selepas kelas tamat. Link e-sijil boleh diisi dengan email e-didik, MOE, MyJawi dan MyGuru. Okey, selain itu cikgu akan berikan kod untuk tebus ganjaran semasa kelas dijalankan. Okey, jadi cikgu akan berikan kod yang pertama. Kod yang pertama ialah A2. A2. Okey, jadi sila fokus pada isi pelajaran yang akan disampaikan oleh Mr. P. InsyaAllah moga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Jadi tanpa membuang masa, cikgu serahkan kelas kita kepada Mr. P. Silakan Mr. P.
Okay, so thank you Cikgu Izian. Okay, so saya Cikgu P, okay, P Kok Hua dari Kolej Tingkatan 6 Tun Fatimah. So minggu ini sehingga saya lah, okay, sebagai presenter kepada anda untuk panitia fizik, okay. So untuk pengetahuan anda, kita ada 2 kelas. Kelas fizik SPM untuk tingkatan 4 diadakan pada setiap Jumaat pukul 9.30 malam dan sekarang kita sudah sampai tajuk 3.1 Hukum Kegravitian Semester Newton siri kedua. So minggu ini disampaikan oleh Cikgu Rina Rashid. So anda bolehlah pergi channel Cikgu Rina untuk tonton semula apa yang beliau sudah ajar pada minggu ini. Dan hari ini, hari Ahad pukul 2 petang kita ada kelas tuition percuma, okay, dari AYU untuk kelas tingkatan 5. Dan hari ini saya akan menyampaikan tajuk subtitle dia 3.1 Elektrik dan Beza Keupayaan. So ini merupakan panitia fizik SPM Akademi YouTuber Malaysia. Dan hari ini bersama saya di sini ada Cikgu Izian dan juga Cikgu Hasnita. So terima kasih bersama saya pada petang ini. Okay, so today we are going to our new chapter, chapter 3, electricity. So our first subtitle for today's lesson will be 3.1, current and potential difference. So you may get my notes and exercise for today's discussion in my link, where already stated at description and also at the chat room. Okay, so today's lesson we have total 5 learning standard. So our learning standard 1 is about the explanation to the electric field. Okay, so firstly, what is a electric field? So to understand this, let us look at the diagram. This diagram. Okay, so the diagram show a positively charged object Q. So will be this one. Okay, pushing a charge, another charge positive with small letter Q close to it. Okay. So the area around a single charge Q form a field where a small charge experience a force. So that means the area will be at this area. Okay. So there will be a force experienced by the small charge and move towards the to the positive capital Q. Okay. So the field is known as electric field. So the area at this area, which is around the capital Q here, will be known as electric field. So that we can define an electric field is an area around a charged object where an electric charge will experience a force. Okay, so this is the definition about the electric field. Okay, so the direction of the electric field is the direction of the force acting on the small positive charge located in the field. Okay, so the small positive charge referring to the plus, small letter Q lah. Okay, so the electric field is represented in the diagram using line and arrow. So you can look at this GIF, okay? So this line is called electric field line. So the electric field line is directed outward from the positive charge and directed inward into the negative charge. So you can look at this figure. Okay, so positive charge, the arrow is showing at outward, while for the negative charge, so the arrow is showing inward. Okay. Okay, so now let us discuss how we can actually observe the electric field. So we can conduct this experiment. Okay, so this experiment will be like this figure. Okay, so firstly, semolina powder is dispersed evenly on the surface of the oil. So the oil in this figure we're using is olive oil. Okay, so the power supply is switched on. So the power supply here, we need to switch on. Okay, so the semolina powder on the soil surface map out the pattern of the electric field due to the action of the electric field force. So that means when we on our power supply, okay, so we can see the semolina powder is moving, okay, moving to the electrode, okay. So here, this observation is regarding two charged spheres where the electrode is cylinder lah. Okay, so you can see the appearance for the or the distribution of the semolina powder. Okay, and then this one is for the electrode where we're using the shape as a plate. Okay, and then this one is one at the sphere's shape, okay, and another one is at the cluster plate. So this will be the result, okay, we can see. Okay, so from our observation through the experiment, okay, electric field line is always point outward of a positively charged object. Will be like this. Okay, you can look at the arrow. Okay, is out of the positive charged. Okay, so electric field line always point towards a negative charged object. So we like say we using the electrode which is connected to terminal negative. Okay, so the you can see the electric field line is pointed towards the negative charged object. Okay, so when two objects of two opposite charges are placed near one another, the electric field line extends from the positive charged object to negative charged object. So we look like this, okay? So you can see the arrow is come from the positive charged and then move to the negative charged object, okay? Okay, so another one, the electric field line do not overlap one another. So you can see there is not closing over line, okay, like this. Okay, will be not occur, okay, in electric field line pattern here. Okay, so the conclusion, the electric field exists in the space around a charged object. Here will be the electrode, okay, and it's represented by the electric field line. Okay, you can see we represented the electric field as a line and arrow here.
Okay, Mr. P, ada
Ya.
soalan daripada
Oh.
Afi. Dia tanya macam mana sebut dan minyak boleh membentuk medan tu.
Okay, so firstly yang medan tersebut dia adalah insulator, tetapi dia akan bila you on kan dia punya terminal, okay, so dia akan membentuk satu daya elektrik di kawasan tersebut, okay. So kita move balik ke sini, okay. So contoh di sini, okay, bila you on kan bateri, so maksudnya di kawasan sini akan ada electric field. Seperti kalau kita guna magnet. So kawasan yang berdekatan dengan magnet, dia akan menarik metal kan. Okay, tetapi kita tak nampak medan magnet tersebut. Tapi sebenarnya form 3 kita pernah belajar kan. Okay, so north dengan south. So kita akan lukis juga medan magnet ini dengan menggunakan line dan arrow. Okay, so di sini sebenarnya terminal positif sini akan serupa seperti north pole. Okay, so dia punya arah keluar daripada north. So di sini, sekiranya di sini kita ada terminal positif. So maksudnya kita punya electric field line kita akan lukis keluar lah. Kita akan lukis keluar dan pergi ke negatif. Di sini, seperti yang kita dulu belajar dekat PT3, dia akan seperti north pergi ke selatan. So selatan di sini merupakan terminal negatif lah. Okay, so kita tak nampak field tersebut. Sebab itu kita kena letak sebut semolina ini sebagai movement yang mana kita tak nampak.
Kalau buku teks dia guna biji sawi pun boleh kan?
Boleh.
Biji sawi, bijan.
Ya. Sebarang yang mana kita sebenarnya nak tengok pergerakan sebut itu yang menunjukkan pergerakan charge positif ke charge negatif objek. Okay ya? Okay, so harap saya menjawab soalan tersebut. Okay. Okay, so the next conclusion here will be the pattern of the electric field line depends on the shape and the numbers of charged object. So dia akan mengikut bentuk. So bentuk di sini kita ada spheres yang diwakili oleh elektrod yang jenis silinder dan bilangan kalau satu sahaja kita akan nampak keluar sahajalah. Kalau kita dua, dia akan kalau positif ke negatif dia akan tarik positif ke negatif lah. Sekiranya dia adalah dua-dua charge yang sama, dia akan berlaku repel. Nanti kita akan tengok dia punya corak bersama lah. Okay? Okay, so Di sini kamu boleh nampak, okay? So let's say we're using the plate electrode, okay? So we'll draw the line like this, okay? Okay, so let us practice together, okay, what we actually can observe, okay, by using the experiment just now we explained, okay? So sketch the electric field set out by the electrode as shown, okay? So mark the direction of the field force, okay? So you look at this. So as mentioned, when the object charted as positive, so the electric field line will be outward. That means come out, okay, from the positive charged object, okay. While for the B, for the negative charged object, so that means the line of electric we draw will be go into the charged negative object like this, okay. And then for the C, you can see here will be the positive, here will be positive. So that means both will be come out. But here we will see that the line will be like this. Because they are like charged, they will be repel to each other. Dia akan menolak antara satu sama lain. Okay, but the arrow will still draw from the positive charged object lah. Okay. Okay, and then for the D, there will be one positive and one negative. So the charge will be, so the electric field line will be draw from positive to negative like this. And how we can draw the line, we will observe the semolidum powder movement. Okay, we will see the powder is moved to negative, so that we draw based on our observation. And the electric field line will be represented as the arrow and line. Okay, so the arrow showing the direction for the charged object. Okay, will be like this. And here, the shape of the electrode is platform. So that means here we can see positive and negative plate. So the movement also the same, will be come up, okay, from the positive plate to the negative. Will be like this. Okay, again, the line showing the electric field line, arrow showing the direction. So from here, the case for F will be also from positive to negative. Okay, so it will be like this. So remember, the line is not close over each other lah. Okay, it will be like this lah. Okay, so here I show you the clearer answer. So it will be like this lah. So positive charged object showing the arrow out of the charged object, and the negative charged object, the arrow will be go into the charged object. When go to C, both which they have the same charge, they will repel to each other. So the line here showing the repel action here. Okay, and as per mentioned, when both is the unlike charge, okay, so they will from positive charge to the negative charge. For the platform shape electrode will be also like this. Okay, so the arrow showing the direction went from the positive charged plate to negative charged plate. Okay, and then F will be like this lah. Okay, again, you can see the arrow is come out from the positive plate. Okay, and then the arrow for the another side of the negative charged will be from outside to the negative charged object here. Okay, so I hope that you all can understand how to draw, okay, the magnetic field line, okay, in the magnetic field, okay, which is showing by the line and the arrow. Okay, so next we will go to define strength of electric, electric field. Okay, so what is the electric field strength? So we're using the simple E to indicate the electric field line. So the electric field strength, is represented at E, okay? So the electric field strength is defined as force adding on a unit of positive charge placed at a point in electric field. Okay, so this is the definition. Okay, so you can look at the figure, which is actually the explanation for the definition. Okay, so this is the figure. Okay, so let's say the positive charged Q is placed on an electric field as diagram. So will be this. Okay. Okay, so the line showing the electric field line. Okay, it's the electric field here lah. Okay. Okay, so the electric field strength can be written as this formula. Okay, so where the force of electric adding on a certain amount of the charge here. So we count up the formula will be F over Q. Okay, so from here you can see the F is the force of electric. Okay, and the Q will be the quantity of the electric charge. Okay, again, the capital E represent as the electric field strength. Okay, so this is the symbol we use. Okay, so how we get Newton per column? So you can using this formula. The F, the unit is Newton, and the Q, the unit will be column. So we get the unit for electric field strength will be Newton per column lah. Okay, so here is another type of the electric field strength where they are in the uniform field. So how we can create a uniform field? So here we using two plate where the distance is always the same, which is equal to D. So that means that the E where the electric field strength at any point between these two plates will be the same. Okay, you can see they check the electric field strength here, and here all is equal. Okay, because the distance of the plate between the plate is the same. Okay. Okay, so two parallel plates separated by a distance D. Okay, D, and connected to the battery with a voltage V. So if you produce a uniform electric field here, okay, electric field strength here, which is with the symbol of E. Okay, so at any point between the plate, okay, the strength of the electric field, which is represented as E, is adding on the charge is always constant. Okay, so that means at any point between these two plates, they have the same value of E lah. Okay.
Mr. Pei, ada yang tanya lagi. Afi tanya, Q tu kita kena kira atau bagi dalam soalan?
Q. Okay, so ini akan dibincangkan pada learning standard 4 dan 5. So dia mungkin dia akan berikan Q, mungkin dia akan berikan sebarang E ke. Okay, so based on the question lah. So kita akan gunakan formula di mana dia beri, dan mana yang kita perlu carikan. So mungkin dia beri, mungkin dia kena cari. Okay. Nanti kita boleh bincang bersama soalan tersebut lah. Okay, so seterusnya the electric field strength between the two plates depends on. So that means based on our figure, so what is the factor affecting the electric field strength? So here there are two factors affecting the electric field strength. The first will be the voltage between the plate and the separation distance between the plate. Okay, so from here, the higher the voltage, the stronger the strength of the electric field. Okay, so that means the higher V, the field strength will be higher lah. Okay, so the relationship will be direct proportional. Okay, And then the next will be the separation distance. The greater the separation distance, the smaller the strength. So that means if I say the distance between the plate is higher, so that means the strength will be decreased. Okay, so the relationship between them will be inversely proportional. Okay. Okay, so the next, so we come up the equation. So where E will be equivalent to the V over D. So this will be another formula where we can calculate the electric field strength. Okay, so the unit for the E here will be volt per meter. Distance will be meter for SI unit. So we get Okay, so we get our unit for the E will be V per meter. Just now we using the formula where the E equal to F over Q. So the unit will be Newton per Charge. So that means the Newton per Charge will be equivalent to volt per meter. Both of these showing the same units okay, for the electric field strength. Okay, so you can look at here, the unit of electric field strength is equivalent to Newton per Coulomb. Okay, we're using two formula to calculate the electric field strength, where F showing as the electric force, Q will be the charge, V will be the voltage, and the D will be the separation distance. Okay, so just now, okay, because student asked how we can calculate. So that means the question will given you the value. Okay, for example, the question can give you E and F and ask you to count for the Q. Okay, so or question can give you another information So as long as the information is enough, okay, so we can get the parameter where the question asks to solve okay. Okay, so the next, okay, we go to our checkpoint. Okay, question number 2. Okay, so here is the question regarding the experiment. Okay, so the diagram show an arrangement of the apparatus to show the existence of an electric field. Okay, so just now I already mentioned that this experiment we want to show that there are actually the electric field exists between these two electrode. Okay, so showing by the movement of the somalina powder. Okay, so based on the diagram above, why olive oil is used? Why we not use others material? Okay, so this is because the olive oil is a good insulator. Okay, so that means we just need to use the insulator. Actually, not only the olive oil Okay, so cooking oil actually is also can, as long as there is a good insulator. Okay, and then the next will be the what happened to the semolina powder when the high voltage supply is switched on. So as per mentioned just now, when the power supply is switched on, so that means we have the electric field exists at this area already. Okay, will be quite similar to we have two magnets, north and south. So that means when we have one or two magnet here, so they will have the magnetic field at this area. So any magnetic material will be attracted Okay, so here will be almost the same. Okay, just the field is different. For the magnet, there will be the magnetic field exists at the area closer to the magnet. So, and here the electric field will be at the area where we have the charged object, positive or negative. So here will be positive at this part and negative at this part. Okay, and then the movement will be, you can see the somalina powder move from the terminal positive here to the negative terminal here. Okay. Okay, so form a pattern line connecting the positive and negative electrode. Okay, so as per mentioned, explained just now. Okay, so the movement will be the line from the positive charged electrode to the negative charged electrode here. Okay, okay, so the C, so state the change of the strength of the electric field when the potential difference of the high potential supplies is increased. So what's the changes for our strength? So that means the question asks us about the E. So the strength will be increased or decreased, okay, when the voltage is increased. Okay, so you can apply the formula we just learning at learning standard 2 here. Okay, so we will using this formula. Okay, here we have two formula. The first formula here will be relationship between the electric force and the charge. And then here will be the voltage to the over the separation distance between the plate here. So the D will be here lah. Okay, but here the question asks when we increase our power supply, so that means our voltage will be increased. So our E will be increased. So this one can be discussed by using a formula. Okay, so the answer here, the strength of the electric field increase. Okay. Okay, so a charge of 0.15 C is placed in an electric field experiencing a force of 0.045 Newton acting on it. So what is the electric field strength exerted on the electric charge? Okay, so seperti tadi ada Afi tanya kan, betul tak? Okay, so adakah kita perlu kirakan Q? Okay, so di sini apa yang dia tanya? Dia berikan Q, dia berikan F kan. So bila kita tak pasti apa dia punya parameter, okay, so we can look at their units. So the column showing that this is the parameter Q. Okay, and then the Newton here represented as F. Okay, so what's the question trying to ask us? So ask us about the electric field strength. So there will be E. Okay, so from our discussion just now for the learning standard 2, the formula for the relationship between E, Q, and F will be with this formula. E equal to F over Q. So the question already given you F and given you Q. So that means you can just divide the value 0.045 to 0.15. Okay, so you can get the answer. Okay, so the question give Q, give F. So what is the value for E? So we're using this formula and then we can get our answer. So make sure you get your answer with correct unit. No? Okay, so I hope this one can help Afi, okay, to more understand how we apply the formula to get the relationship between the parameter given in the question. Okay. Okay, so the next will be the checkpoint question number 4. Okay, so this is one of the question come out from the 2017 paper 2 section B. Yes, okay, so I feel very good. You get 0.3. So, okay, so make sure, well done. Okay, good. So make sure you state your unit during the exam. Okay, let's say you just give 0.3 without the unit, so the answer will be also considered is wrong. Okay, Afi, so please take note of this. Pastikan Anda tuliskan unit dalam jawapan Anda. Okay, okay, so diagram show the apparatus used to produce the electric field between two electrodes. Okay, so as per discussion, okay, so this is the experiment to let us see the electric field, okay, in these two plate. Okay, but here we have X using the cylinder, so they will have the shape like spheres lah. Okay, another one Y will be the considered as a plate shape lah. Okay, Okay, so draw the pattern of the electric field that is formed between the two electrodes. Okay, so the first electrode will be positive. You can see the connection to positive. So positive means the arrow of the line will be outward. Okay, and here will be the sphere's shape lah. Okay, when you draw the electric field diagram. Okay, and then at the another one is a plate shape and connected to the negative terminal here. So when connected to negative terminal, so the arrow will be inward. Okay, so this is two key information you have to know. Okay, okay, so you have to draw lah. The diagram will be like this. So as per mentioned, for the terminal positive will be sphere's shape and the arrow is outward. Okay, you can see it's outward. And then the Y will be plate form. Okay, in plate shape. Okay, and then the arrow will be inward. So here will be moved from the positive charged object to the negative charged object. Okay, so 2 marks, arrow, 1 mark, okay, and the shape of the electrode, second mark. Second mark, okay? Okay, so another one is explain why EHT is used. Okay, so the EHT is extended high tension. In BM is voltan lampau tinggi. So why we need to use high voltage lah, here. Okay, so the answer here will be to provide large potential difference between the two terminals so that the electric charge can flow. Okay, so that means in this answer, we know that if we're using the small potential difference between these two terminals, so maybe we cannot see the clear movement of the semolina powder, okay, in your experiment. Okay, so this is the advice answer. Okay, so 1 mark only. And the question come up in the year of 2017 now. Okay, so this is a partial question which is related to our topic today. Okay, so we go to our next discussion. Okay, learning standard 3, which is regarding the behavior of the charged particles in an electric field. Okay, so we have 2 examples here. So you can look at the behavior of the charged object in an electric field. Another one is at the candle frame. Okay. Okay, so the first, we'll see the behaviors of the charged particles in the electric field. So this is a diagram. Okay, so you can see there is the polystyrene ball, which is coated with the metal paint. Okay, and hang with the nylon thread between 2 plates, which is set here X and Y. And here you can see X will be connected to positive terminal, so will be represented as the positive charged object here. Okay, and then the negative here connected to plate Y. So the plate Y will be represented as the negative charged object. Okay, so diagram A show the line polystyrene ball coated with conductor paint. Okay, so suspended on the nylon thread between metal plate X and Y. Okay, so X will be connected to positive terminal and Y is connected to the negative terminal here. Okay, okay, so first, when the EHT supply is switched on, so plate X is charged positively. Okay, because the X is connected with positive terminal. So here will be charged positive. Okay, another plate Y will be charged negative because it is connected to the negative terminal here. So due to the polystyrene ball being in neutral state, okay, you can look at the figure. You can see the force to right and left will be the same. So that is in neutral state. Okay, so the ball remain in the center as shown in the diagram B here. So this is because the electrical force F, okay, adding is balanced. Okay, you can see the electric force here to terminal X to black X and to black Y is the same. Okay, they are in neutral state. Okay, and the experiment here, the first you can see from the figure C here. Okay, so when the ball is pushed to the black X, which is positive charged, okay, so the ball which is coated with the metal conductor, okay, will be charged positively, so become positive lah. So when it become positive, both the plate X and the ball coated with conductor will have the same charge already, so they repel. Okay, mereka menjadi charge yang sama, jadi mereka menolak. Okay, so the ball is pushed towards black Y. You can see the arrow here. Okay, show in the diagram C. Okay, and then D, what happened? So when the ball coated with conductor move to D, move to the black Y. Okay, so that means the ball which is positive will be neutralized and then change to negative. When change to negative, they will have the same charge already, so they repel to each other. So the coated metal ball will be moved towards X again. Okay, and the movement of the coated ball here will be repeated. Okay, so when a ball touch the negative plate Y, so the positive charges of the ball will be neutralized. Okay, and the ball is now charged negatively and repel towards black X. So the diagram D, you can see okay, what this statement state here. So the process is repeating and the ball oscillate between black X and Y. Okay, then the number 5 discussion here is related to the factor affecting the rate of oscillation. Okay, so that means the ball will be swing more faster or slower. So here we have 2 factors affecting the movement speed, okay, for the oscillation ball here, polystyrene ball here. Okay, so first will be affected by the EHT voltage supply. So when the voltage is higher, okay, so the faster the rate of the oscillation. Okay, and second is the distance between the black X and Y. So when the distance between the black X and Y is smaller, okay, so the rate of the oscillation will be also higher. Okay, so that means you want to see the higher oscillation of the polystyrene ball, which is coated with conductor. So you can increase the voltage of the EHT, or you can decrease the distance between the black X and Y. Okay, these 2 factors affecting the rate of the oscillation. Okay, so the next will be the effect of electric field on the candle frame. Okay, so you can see the frame here separate. Okay, so why? So here will be the discussion. When the polystyrene ball is replaced by a candle frame, okay, so we replace with candle frame. As shown in diagram A, the candle frame will split. So you can see the candle frame will split to 2 parts. Okay, so this is a first observation. You can see both of the candle is split. Second, you can see the portion of the frame towards the negative plate. So here is a negative plate. The portion of the frame is bigger compared to negative. Why? Okay, this is observation. Why? Okay, so here is the reason. So the hot candle frame ionizer move in the air molecule around here. Okay, so that means when the candle is, because the candle is hot, okay, so they will be ionize the molecule around the air here. So that means initially the air molecule is neutral. When we have the frame, so the frame will be ionize the neutral molecule in the air, so become positive and negative lah. Okay, so this is the first statement here. Okay, so they change from neutral to ion positive and negative charges. Okay, so the heavier and larger positive ion are attracted to positive negative plate. So for positive ion, they are bigger. Compared to the negative charge, they will be smaller. Okay, they will be smaller. So that means as the positive charge is bigger, okay, they're attracted to plate negative with more larger portion. Okay. Okay, so this causes the large portion of the frame to follow the positive ion move towards the negative plate. So the lighter negative charges drive the thinner frame. So here will be thinner because the electron or charge negative is smaller. Okay, so small portion of the frame will be attracted to the positive plate here. Okay, so this is the reason. Okay, okay, so Cikgu Izian, kita boleh break sekejap.
Okay, sebelum kita break, cikgu bagikan kod yang kedua iaitu 93. 93. Okay, kita lihat sebentar.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okay, kita sambung semula. Silakan Mr. Pei.
Okay, so thank you, Cikgu Izian. Okay, so we continue the another two question actually regarding the learning standard 3. Okay, so question 5. Okay, so diagram 1.1 show the polystyrene ball are coated with aluminum paint. So here already mentioned to you the conductor paint here you'll be using the aluminum. Okay, it's hang in an electric field between two metal plate here. Okay, so plate X and plate T. So the plate X will be connecting to positive terminal. So here will be positive charged lah. And plate T will be connect to negative plate, so be negative. Okay, so what is the meanings by electric field? Okay, just now I already mentioned in our notes. Okay, so it's an electric field where the area around the charged object will experience a force. Okay, so this is the definition. So that means this is the first figure we discussed at the charged object Q. At center here, the small charge will be experience a force. Okay, so this area is the electric field lah. Okay, okay. Then the second, state the change on the strength of electric field when the potential difference of the high voltage supply increases. Okay, so what is the impact for E when the V increase? So we're using formula to explain. Okay, so here when the potential difference increase, so the strength of the electric field will increase lah. Okay, will be increased. Okay, and then B, the polystyrene ball then is touched to the negative plate. So based on the diagram, name the electrical charge on the plate X and T. Okay, so as per mentioned just now, S connect to positive and T connect to negative. Okay, so S will be positive charge, T will be negative charge. Okay, so state the type of charge received by the polystyrene ball. Okay, so when the ball touch to T, okay, so that means it will be have the negative charge lah. Okay, as T is negative plate. Okay. Okay, so what happened to the polystyrene ball when it is released from the negative plate? Okay, so when the ball is released from the negative plate, it will move towards the positive plate lah. Okay, so will be attracted to the positive plate or repelled away from the negative plate. Okay, because the polystyrene ball when touched to the negative plate T here, it will be negatively charged. Then when they have the same charge, they will repel to each other and move to black S, which is positive lah. Okay, so the polystyrene ball in diagram 1.1 is replaced by a burning candle as shown in the diagram. Okay, so the diagram will be this. Okay, so what's the observation you can see? So when we discuss about the effect of the electric field in the candle frame, so we discuss which portion will be bigger. So as per mentioned, the frame portion will be larger towards the negative plate, okay, because the positive charged or ion will be bigger compared to the negative charge lah. Okay. Okay, so explain why the shape of the candle frame observed as in diagram 1.2. Okay, so firstly, you must discuss the molecule ion around the frame is ionized lah. Okay, so the heat of the burning candle produce positive and negative ions. Okay, and then number 2, the positive ion which are heavier is pulled towards negative plate. Over here. Okay, with a large proportion frame. Okay, and then here is another question in 2015. Okay, section A, question number 8. Okay, so the frequency of the oscillation of the metal coated polystyrene ball can be increased by using one of the method listed in the table 8.1 here. Will be this table. Okay, so here we discuss about 3 factors. So distance between the 2 plates, mass of the metal coated polystyrene ball, and the voltage of EHD supply here. Okay, so the first, based on the table 8.1, state the suitable method to increase the frequency of the oscillation. So that means they want to increase the rate of oscillation of the polystyrene ball. Okay, so the first asks you to choose the distance between 2 plates must be longer, medium, or short. So for sure, must be short lah. Okay, based on this formula, we know that the strength of the electric field is affected by the distance of the plate. Okay, so when the distance decreases, the strength will be increased. So the oscillation rate will be increased lah. Okay, so we must choose the shorter. Okay, reason to increase the strength of the electric field. So you see, we just need to discuss this with using the formula. Okay, so okay, Afi cakap kaedah Z. Okay, so rasanya betul kan? Sebab di sini you will nampak X dengan Y sudah salah. Okay, so kita tengok akhir ni betul tak? Okay, so rasa betul lah. Tapi discussion di sini kena berikan reason yang betul. Okay, so the second will be discuss regarding the mass of the metal coated polystyrene ball. Okay, so for sure, we will using the lower lah. Here got medium, high, and low. So we'll choose the low. Okay, because the lower the mass of the ball, they will be swing faster lah compared to the heavy ball. Okay, so this is the reason. And then the next will be question asked regarding the factor of voltage of EHT. Okay, so just now we know we choose short, low already. So here the EHT must be high. Okay, so here we can explain based on the formula again. Okay, so with the higher voltage, the strength of the electric field will be higher. Okay, so we choose high. Reason, the higher the voltage, the stronger the electric field. So that means we can always try to relate the formula, okay, to our discussion. Okay, okay. So based on the answer in A1, A2, and A3, choose the most suitable method to increase the frequency oscillation. So correct now, okay? So Hafi, well done. So it's Z, method Z. Okay, and then the question continue to ask about when we replace the new nylon thread with the copper thread. Okay, so what happened to the motion of the metal coated polystyrene ball? Okay, so that means change from insulator to conductor actually. Okay, okay, so the ball will be not move at all. Okay, so the ball will be at the middle here. Okay, okay, so why? The electron on the ball are conductor away by the copper thread. So that means the electron will be moved away through the copper thread. Okay, so the ball become neutral. So it is not affected by the electric field. So when neutral already, so that means no any effect to the ball. Okay, when we replace the nylon thread to copper thread. Okay, okay, so we go to our learning standard 4, which is to define the electric current. Okay, so these last two learning standard have more discussion with the application of formula. Okay, so electric current. So what is the electric current? So to understand the definition of the electric current, you have to understand what is the charge electric. Okay, so the charge electric will be Q okay. Okay, so it's defined as the source of the electric field. So the unit is coulomb, what we already learned, okay, just now. So the formula for Q will be Ne. N represent as the numbers of electron, and the E will be the charge of an electron. So the charge for one electron will be 1.6 times 10 power negative 19 coulomb. Okay, so that means if we have more electron, so the charge will be higher. Okay, okay, so then we define what is the current. So the current is the rate of flow of the charge electric. So that means it's a flow of the electron. Okay, it's a flow of the electron. So the unit we use will be ampere. Okay, current will be ampere, and we can use the another formula. This one will be coulomb per second. So where we can get this formula? From this equation. Okay, where is the we relate it from the definition so flow of the electron, flow of the charge will be Q at the certain of the time. Okay, so the Q will be the unit C, time will be second. Okay, so that means there will be coulomb per second. Okay, so from this formula, we can get another formula for Q. Q will be I and T. Okay, so we have two formula for Q here. Q equal to Ne or Q equal to IT. Okay, so 1 ampere is defined as what? So 1 ampere is a fixed current that flow through a wire when a charge of 1 coulomb. Okay, 1 coulomb flow through the wire in 1 second. Okay. Okay, so we go to the calculation discussion. So question number 7 here. Okay, solve each of the following problem. So the question first will be, if 30,000 column of charge flow through a light bulb in 50 minutes, calculate the current passes through the bulb. Okay, so from here, the information, you can look at their unit. So the C indicate this one will be Q. Okay, and then here minutes will be time second. So we have to change the minutes to second, which is the SI unit. Okay, and then calculate the current, which is I. So from our discussion, Q will be equal to IT lah. Okay, then you can get the I. We rearrange this formula to Q over T. Okay, so here this 2 is given. So what is the I? So I we calculate by using Q, which is 30,000 over the time. 50 minutes have to change to second lah. Okay, so we get the answer will be 10 ampere or 10 column per second lah. Okay. Okay, yes, good. Okay, Hafi, very good. Okay, so let's continue learning with me here. Okay, so if the amount of the charge carried by one electron is 1.6 times 10 power negative 19, so this one will be E, right? Okay, so calculate the numbers of electron in C. So C will be Q. Okay, C will be Q. So question given us Q is equal to 1, and then E is equal to 1.6 times 10 power 1 over 1 power negative 19. So what is the numbers of electron, which is N now? So we have formula Q equal to IT. We have another formula Q equal to NE. So that means here, how we can get, so we actually need to use 2 formula here already. So first, Q equal to NE. We straight away can use this one lah. Q equal to NE, Q is 1. And we need to get NE will be this. So we use 1 formula, we get the answer lah. So you have to choose lah. You have to choose the second one. Okay, so you substitute all the value given and you get, okay, you get the N will be equal to 6.25 times 10 power 18 lah. Okay, it's also quite straightforward question here. Okay. Okay, then the C. Okay, C, I already accidentally give all the answer here. Okay, never mind. We see how we can get this answer lah. So if microammeter show a reading 20 milliammeter, so milliammeter you have to change to ammeter by divide 1000 lah. So we get 0.002 lah. 0.02. Okay, ampere. And then the time second given by the question will be 2 minutes. So you have to change to second by multiply 60. Okay, and then the E given as 1.6 times 10 power negative 19. Okay, so question asks, determine the numbers of the charge lah, N. Okay, so firstly, you can get the C value with this formula. Okay, so we substitute the value given, we get 2.4, and then we get N by using another formula. Okay, so we get the N will be 1.5 times 10 power 19. Okay, so or you can straight away using like this IT equal to NE. So N equal to I times T over E lah. So I is given 0.02, T is 2 minutes, and E is 1.6 times 10 power 19. So you will get the same answer also lah. Okay. Okay, so next we go to our last learning standard. Define potential difference, okay? Okay, potential difference. Okay, so work or energy to move one column of charge between 2 points in an electric field. Okay, so this is the definition for the potential difference. Okay, the unit we use for the potential difference will be volt or joule per column. Okay, because our formula using here, which is from the definition, work or energy, okay, move between 2 points, okay, and moving one column of the charge lah, so will be Q. Okay, so W will be with the unit of joule, and Q will be with the unit of C. So we get joule per column, which is have the same equivalent unit and known as volt lah. Okay, so 1 volt will be potential difference between 2 points if 1 joule, okay, 1 joule of the energy used to move one column of charge between 2 points. So what is the 2 point mentioned here? Okay, so you can see together with the discussion with this figure. So from the figure here, you can see a battery is connected to a bulb. Okay, so it creates an electric field along the wire. Okay, so here we have the electric field. So the terminal positive P is at higher electric potential. So because here P is connected with positive, so here will be higher potential. Okay, and then Q will be lower potential because it connect to negative terminal. Okay, okay, so when the switch is on, okay, here switch is on, the potential difference between the two terminal causes the charges to flow across the bulb in the circuit and light out the bulb. So that means when you switch on, the potential difference between these 2 points will be occur lah. So the potential difference here will be, it will try to change the energy, electrical energy to bulb, which is light and heat energy. Okay, so the work done to change the electric energy, okay, to light and heat energy. Okay, so they will be because of the potential difference. Okay, okay, so what is done when the electrical energy carried by the charges is dissipated as heat and light. Okay, when closing the bulb. So different conductor have different resistance of the current to flow. Okay, for example, copper will be considered as a low resistance conductor lah. So it will be allowed more electron to flow through. Okay, so this is one of the example. Okay, I think will be discussed by Cikgu Hasita, right? Next lesson. Okay, okay, so we go to our last checkpoint. Okay, regarding this learning standard 5. So all will be regarding the calculation. Okay, so we are using our another formula we just learned here. Okay, so when lightning strike total charge of 50 coulomb, okay, move from the cloud to the earth, and the energy dissipated here will be 1.5 times 10 power 12 joule. Okay, how big is the potential difference? So the question asks W. C will be Q. Okay, so given W equal to 1.5 times 10 power 12, Q will be 50. So what is the V? So we just using the new formula we learned in this learning standard 5, W over Q. So we substitute W, we substitute Q. So we get our answer 3 times 10 power 10 V lah. Okay. Okay, and then the B, potential difference 240 volt. Okay, so here the value of V is given. Is applied across the lamp, how much electrical energy is changed into heat and light? Okay? Yes, okay, Afi, the answer for just now, okay, 10 powers of 10, okay. Okay. Is it just now one? Yes, okay, correct, okay. So good, very good. Okay, so we do together, okay, for the last section here, okay. Okay, so how much the energy change? So that means the question asks you about the value of work lah. Okay, and the current flow here will be I 2 ampere. And then the question give us another will be time, which is 10 seconds. Okay, so we know our formula, V equal to Q, W over Q. Okay, so how we can get Q? So here we do know what is a Q, but we know Q can get from the formula, from learning standard 4, we learned already, IT. So I is 2, T is 10. So okay, so we get Q and we use the learning standard 5 equation we learned, we get the answer of W, which we arrange the W equal to V times Q. Okay, so first we always list out what is the parameter given, okay, and then what the parameter the question asks us to find out. Okay, so firstly we get our value of Q first with the multiplication between current and time. So we get 20 column. Okay, and then we rearrange our formula. Okay, we get W equal to V times Q. Okay, so we just substitute our V 340 with our Q we just get. Okay, so what's the value we get? Okay, so we get 4,800 joule. Okay, so Hafi, is it you get same answer with me? Okay, so you can show when you already finish this question. Okay, so that's all for my sharing regarding the subtopic of 2.1. Okay, so thank you. So I pass to Cikgu Izian.
Okey, terima kasih Mr. P. Okay, Alhamdulillah dah selesai kelas kita pada petang ini. Cikgu nak ucapkan tahniah kepada semua yang setia sehingga akhir menonton dan bertanya soalan. Okey, sebelum kita tamatkan sesi siaran langsung hari ini, cikgu mohon tutup ruangan chat dan klik butang subscribe dan aktifkan ikon loceng supaya kamu tak terlepas sesi kelas yang seterusnya. Dan juga jika anda suka, bolehlah klik like dan share kepada rakan-rakan di media sosial kamu untuk kita sebarkan ilmu dan juga beroleh kebaikan. Okey, jika dah boleh tekan subscribe, kalau dah boleh tekan type done di ruangan komen untuk tanda terima kasih anda kepada cikgu Mr. P kerana telah memberikan kelas kita hari ini. Okey, jadi sebelum tu cikgu nak berikan kod, lupa kod yang terakhir ada dua number lagi iaitu 86. Okey. So boleh gunakan kod terakhir tu untuk tebus rekod kredit Okey, jadi mungkin link sijil boleh didapatkan nanti di bahagian chat. Okey, so sila ambil perhatian, link tersebut akan tamat dalam tempoh setengah jam selepas live ini. Okey, jadi pastikan anda login dengan email edidik, MOE, MyGuru atau MyJawi sahaja. Okey, jadi sebelum link rekod kredit pelajar pun dah ada untuk anda tebus ganjaran. Okey, jadi sebelum cikgu tamatkan kelas, cikgu mungkin boleh jemput Cikgu Asnita, Ketua Panitia kita untuk memberikan sepatah dua kata.
Okey, terima kasih Cikgu Izian. Bismillahirrahmanirrahim. Assalamualaikum dan selamat petang semua. Pertama sekali terima kasih Mr. P. Satu penerangan yang sangat jelas bagi saya dengan banyak contoh Tajuk ini memang antara salah satu tajuk yang sangat banyak pengiraan di sana, sangat banyak formula. Jadi Cikgu harap pelajar yang telah mengikuti kelas ini, yang pertama anda kena perhatikan cara untuk kita melukis medan magnet dengan betul lah. Tadi telah ditunjukkan oleh Mr. P. Dan yang kedua, macam mana kita nak selesaikan masalah yang melibatkan arus dan beza keupayaan. So sebenarnya keyword yang ada pada soalan itu sendiri, anda kena tahu macam mana nak keluarkan maklumat yang diberi dan tentukan apa formula yang boleh digunakan. Jadi teruskanlah bersama dengan kelas tuition percuma Akademi YouTuber. Banyak lagi siri-siri yang akan datang, insya-Allah. Minggu depan kita akan bercuti ya Cikgu Izian, sempena Raya Haji. Untuk subjek fizik kita cuti seminggu dahulu. InsyaAllah kita akan kembali minggu yang akan datang, iaitu untuk kelas tingkatan 4 bersama dengan Cikgu Rosmawati dengan masih lagi di tajuk 3.1 ya, tajuk yang agak panjang. Dan insyaAllah untuk tingkatan 5 hari Ahad 2 petang Cikgu akan sambung dengan 3.2 iaitu resistance, rintangan. Okey, itu saja Cikgu Izian.
Okey, terima kasih Cikgu Asnita. Okey, mungkin Mr. P ada sepatah dua kata untuk ada anak murid yang menonton. Silakan.
Okey, so terima kasih. Okey, so Cikgu Izian dan Cikgu Hasita bersama saya petang ini. Okey, so di sini terlebih dahulu saya ucapkan selamat Hari Raya dulu lah. Okey. So terima kasih lah. Okey, Cikgu Hafiz, saya nampak dia punya last soalan pun jawab betul. Okey, so harap Hafiz dan juga pelajar lain boleh jemput lagi lebih ramai untuk kelas kita, kelas AYU percuma ini. So pasti anda dapat sesuatu yang manfaat, mendapat keputusan yang sangat baik bersama kita. So thank you.
Okey, terima kasih Mr. P. Okey, jadi cikgu nak ucapkan terima kasih banyak-banyak kepada semua penyokong Akademi YouTuber. Doakan kami terus kuat dan bersemangat untuk menjalankan kelas tuition percuma dan membantu dalam membangunkan pendidikan Malaysia. Okey, akhir kata daripada cikgu. Sekian saja. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.